This episode of 26.1 AI Podcast, we welcome AI practitioner and educator Jennifer Shin. She shares with us her circuitous route to becoming an AI practitioner and also what she observes with her students as they launch in careers for data science and AI.
Hi, Don. Hi, Brian. Glad to be here.
So happy to have you on. So, what have you been up to lately? I see a ton of things on your LinkedIn.
Yeah, actually, it's funny. The LinkedIn's the condensed version of things I've been up to, so it doesn't have everything. I think, yeah, this week I did a lot of, I guess, interesting things in the space of data. For instance, like last month, I was at a conference at ICERM, which is the Institute of Computational and Experimental Research in Mathematics. I presented some work there. Yeah, and we're going to do some follow up things with them, and then, and I also just talked to someone from the Natural History Museum in New York City because I presented some work there in August, and we're talking about collaborating again on working on space data, which is super cool. Other than that, just doing what I usually do, just doing the day job thing, working on some technology, and then also teaching.
How did you get into this space? Because I mean, you're really prominent in the space now. But what started this in your life?
That's a good question. I think in terms of the work, so I think there's a difference between the work that I've done and how I ended up here, and then of course career or job wise. In terms of the career, I was starting out in private equity, hedge funds, and consulting, and the economy crashed, which then made me kind of take a step back and think about, where I saw growth in the industry. And, I think it's a very difficult experience to go through when everyone promises you all these things when you're in school, right? Like if you do this and you're on a track, you'll have all the success. And of course, 2008, that was not the case for most people who are, in the industry and finance, especially in New York. So I decided I'm going to look at the industry and do what I do for my clients and figure out where do I see growth. And at the time, technology was the only place where I saw growth from an industry standpoint. And then from the work that I was doing at these private equity firms, which is working with data, I felt that there's such a good opportunity to actually apply things I learned in school, especially mathematics, that I decided I wanted to do something in the space of data and basically tried to go back to school for a PhD. It's a whole long story, but basically ETS screwed up my subject exam score. I got rejected from a record number of schools, had to choose between going back into industry where I didn't think that the jobs out there were the right fit, or starting my own business. And I ended up starting my own business and basically being in data science just before data science became a term that became more popular.
Going, Jennifer, you're Korean. I'm Korean and Chinese, and you do a lot of mentorship. And I think East Asian parents have kind of very defined paths for the progeny. Do you have something for that audience, Asian Americans and Asians, in terms of finding their way in a career towards what you're doing now, which is really sexy now? And if you tried to explain it to your parents a while ago, they wouldn't probably approve of it.
Oh yeah, I mean, so my path is very different, I guess, than most people. So when I was in school, I mean, I went to a good school, but I didn't like school. I didn't do very well in my high school, even though it was, very, prestigious, I guess. I ended up dropping out of undergrad when I was in college the first time around. It was not a good fit. I had a lot of things happen in my life. I got a lot of, my parents did not understand, and I got a lot of, heat from them at home, which was also motivating in that I wanted to move out as soon as possible and got a job and worked for a while. I ended up eventually going back to school when it was my decision. And I do think that's an important thing that a lot of, I think, Asian parents don't think about. But, when I went back to school, I wouldn't have done it just because my parents yelled at me or told me to. I mean, that definitely didn't work for them in high school. Didn't work for them. It didn't work for me in undergrad. When I went back, I, eventually went back to Columbia and did my undergraduate degree there and did my graduate degree there as well. That was a decision I made for myself. And I don't think I would have been able to be in this field or done any of the things that I've done if, I just listened to someone above me because, the reality is in America that there are still things like discrimination that exist. And there are these difficulties that our parents don't understand and they really just don't know how to navigate. And being a follower makes you very much less able to navigate those difficulties in life. One of the things that I think I've heard about coming out of industry is that a lot of these Asian American students who do very, very well for a while, they cap, right? They don't get moved up to the higher levels. And I do think that is not unrelated to the fact that if you're being rewarded all the time for just doing what your parents say, that's great when you're younger, but as an adult, when you have to start fighting these battles on your own and your parents can't give you advice on it because they honestly don't know what that experience is like, it becomes much more unsurmountable, I think, if you've never challenged the smaller things in your life and really understood like why you're there and why you're doing what you're doing. The cool thing I will say is, so I was born in Korea. I came to America, eventually became a citizen partly because I was applying to grad school and won the funding. And for about 20 years, I didn't get to go back to Korea because I was so busy working and just kind of figuring my stuff out and doing the jobs. And about, I guess, maybe 2 years ago, 2 years ago, the Korean government actually contacted me and asked if I would come and speak, about statistics and about some of the work that I'd done in data science. So the Korean government, 20 years after I'd last been to Korea, flew me out to Korea to actually go and talk about data science to the government. So, it's like, I feel like that's the ultimate dream for every Korean who's like an immigrant here, is like the idea that the mother country kind of calls you back. It's like we all think this, I think, to some extent, but I think that was an amazing experience to have them actually, fly me over there and like have me speak and have me talk about the work that I'd done. And that was, a really amazing experience for me personally to have that validation, from where I was born.
That is, it sounds like a huge honor, and it sounds like a personal honor and a personal achievement. And I see you have many, and I also see you have many facets to what you're interested in, everything from data visualization to all sorts of data science operations. What other things make you excited? What are the other things that you're most proud of achieving, and what wakes you up in the morning where you're happy to go to work and work on a problem?
I mean, I think that's that's a tough thing, right? So I like my job depending on what they talk to me. Like, I think jobs are jobs, right? One of the things I've learned to do for myself is that, I'm not going to always fit this mold of, what people are supposed to do in the workplace and doing the job that they tell you to do. But of course, you do have to work to pay your bills. So, one of the things I do is I have a teaching job that I do at night. I have, my own research as well as collaborations I'm working on. That's very exciting from a more cutting edge standpoint. And then, of course, I have the day job where I go and, get to lead teams and lead projects and build products, which is cool. And, it's really cool to work on AI. But at some point, regardless of what you're building, things will slow down because it takes other people longer to maybe catch up. Or sometimes there's just certain things that are in place already that are going to take time to change, or you might have to just wait on someone else finishing something. So I think for me, I try to find that balance in my life more holistically, rather than just, I guess focusing more on like getting up for one job. I try to think of it like, what do I have going on for the week, and focus on the, I try to do at least one cool thing for myself, each week. And the cool thing is probably something very nerdy to most people. But, I think it's cool. And I think that's really what motivates me, is the idea that like I get to actually kind of be sort of nerdy and do that. And, it really doesn't matter what anyone says to me or thinks, because at the end of the day, it allows me to give back to society and do things that are going to educate people and really bring value regardless of whether or not I get paid for it.
Listening to you, what I discern is you're on a path to becoming a CEO someday, maybe 5 years out, of a sizable org. And if you were to become CEO as a AI native CEO, what do you think that would look like in the future, 5 years down the road?
Well, I think that's a good question. I think it depends on whether or not I'm, working at an organization that has existing, technologies or patents, and also, whether or not I'm building everything from scratch, right? If you're building something from scratch, it's a very different world, because you have to really think about, do I have enough to commercialize on, and how do you get the most out of everyone that you've hired? Who are the most essential workers, and figuring that out. I think what will be cool in the future is that there's more education, more courses, more interest in the space of working with data and technology. So, it'll be interesting to see, say, who's going to be in the marketplace, who can I hire, what are the skills that they have, right? Because, what I have as a skill set today was very much informed by the things that I experienced. And I think for the younger generation, I'm always excited to see like what they've experienced that then informs their decision about what technical skills they acquire and what their interests are in terms of what they want to do and build. From this perspective, more like, I guess more so on the side of business, it will be interesting to see how much progress the bigger corporations make. I think that's where, from a business standpoint, there will be a really interesting, opening in terms of, what I could add to the marketplace that might be of might be a need or a desire for people to purchase. And I think it'll be interesting to see how much of that is actually like, say, local softwares versus, say, on the cloud or SaaS. I think everyone's going onto these SaaS platforms or AWS and underestimating like how expensive that can be for everything you compute. So I wouldn't be surprised if, say, it goes backwards, right? And I think ultimately for me, it would probably be a B2B that I would always focus on. It's great to go to consumers, but I don't know, just my experience has always been more so in the space of like working with businesses and corporations. And part of that is that I can get more funding faster than, say, going and selling to each customer that I acquire. And that allows me to then fund my engineering teams and fund my AI teams to build bigger, cooler things and not have to worry about every marketing campaign, right? Like it's really hard to build really cool technologies when you're worrying about every dollar and cent. And I think for engineering teams, that tends to be the most stifling thing.
I like the contrast of a business-minded person and someone who's very technology deep, and someone who also has about I think you have like 5 patents. Is that correct?
Along those lines, yeah.
Along
Well,
those
some of them are still, kind of being worked out. One of them has already been granted.
Give or take, yeah. And I don't have as many as you do. I don't have any. But
Jennifer, did you author those yourself, or did you?
Yes,
You did.
I'm sole author of those. Yeah.
Oh, I might need some coaching from you.
Oh yeah, definitely. Give me a call.
I have.
We all could use some coaching. Where do you see it going in 5 years from now? And I know that's a very vague question, but one thing I've noticed, and I'll narrow it down a little bit, is that you're really big into data visualization, and I always think about the discovery of science and the discovery of solving problems and the storytelling of it. Is that going to become easier 5 years from now, given the tool sets? And I did hear the little statement about the economics of cloud computing too. But generally speaking, where do you think it's going regarding the exploration of data science?
Well, I think what's really interesting about all of these things that we talk about, think about when it comes to, where will we be in 5 years? I think so much of it is driven by where, the bigger marketplaces where everyone is interested in going. And yet on a micro level, people tend to behave in certain ways and tend to not change certain behaviors. So there's always this sort of, I think as a scientist, like I'm always worried that like I'll get into some sort of pattern where I'm kind of doing the same thing all the time and thereby not getting around certain limitations I may have that prevent me from making a discovery, right? If you're always repeating the same process, you'll make the same mistakes and therefore may not discover the answer. So I think for me, I'm always very aware of that and trying to avoid that. But I think the majority of people find that having something just kind of, on repeat and doing the same thing, it's a reassuring thing, right? They feel comfort in that. And so there's a tendency, I think, as a society to want to kind of feel like we know things, feel like we can keep doing the same thing. But then, of course, we stagnate, right? And I think it happens. A lot of these things are sort of like business. They're very cyclic, right? There's ups and downs, but we kind of come back to the same place, maybe a little bit, to the left, a little bit to the right, but nonetheless kind of where, in terms of, how we're operating, to the same sort of place where we're doing the same behavior as before. So I think with AI, especially with data visualization, there's so many tools out there that people are using and people are more familiar with it. But I think depending on how it goes in the next 5 years, there may be a bigger need for the educational component where people are thinking more about like, okay, so we have these tools and we know how to use it, but how are we using it? Is it the better way? And really assessing the analytical components of that and not just focusing on the technical components.
Oh, I love that question. You just led me right to it. I'm sorry, Don, if I asked too many questions on this one, but do people understand prediction? Do they understand precision recall?
Well, I have a follow on for this for sure. So
okay.
Everything depends on what field you're in. For one, like as a statistician, prediction is a very different word than in layman's terms. It's another thing that I usually emphasize when I'm teaching is what you say in normal conversation are words you should not use when you're talking to an expert. Because in math or in statistics in these fields, we have very precise definitions for these words, and they're not appropriately used when you are reading things that are marketing material or in the news or covered by media. So I think there's that component of it where you do have to think about, when you say prediction, what do you mean? Is it like layman's terms? Is it something you saw in a movie? When you're talking about statistics, it's not so much a prediction as it is predictive, but really it's more like it's similar to estimation, but slightly different, right? So there's nuance to it. But really that's sort of the difference, in that there's a very specific definition that we go by, and that's across the board. I think the more common example that I talk about is bias. You will always have bias in a model. That's just a fact, right? We're not going to have a completely bias-free model, partly because data is always changing, right? At any given point, by the time I finish running a model, there's more data to be, that exists out there that have changed. So bias is always going to happen. In the way that we talk about bias in like a societal way is not the same way that we talk about bias in statistics. So there is that, that part of it where I think it really, you do have to think about in what context we're talking about these words and our understanding. But I do feel like this is where you have a lot of people who disagree, because no one thought to stop and go, are we actually using the same definition here? Are we actually thinking about these words in the same way? Or are we disagreeing because that's not my opinion of what I perceive as prediction versus what you perceive? But if your definitions are different, essentially you're talking about two different things.
I love that answer. Okay, Don, you can ask your follow-up question. I'll let you.
Oh, thank you. I'm obsessed with Tversky and Kahneman, and I'm trying to urge Brian to read Michael Lewis's project, or The Undoing Project by Michael Lewis, that covers their collaboration, how they came up with their discoveries. And so related to their paper, Judgment Under Uncertainty, Biases and Heuristics, when you're trying to influence a business leader, and typically they'll have a lot of experience in what they know, but according to Kahneman and Tversky, what that leads to is overconfidence in trying to apply it to new knowledge. And what excites me about AI and going there is the evidence and the math. How do you get them to get out of what they think they know and are confident in, to believe in the math and that predictive or statistical basis for making a decision?
Yeah, that's a really good question. I think, in business, it's not as hard as people might think in terms of getting people interested in maybe, learning a little more math or hearing more about the technical or analytical components of it. Partly because, in business, like if you tell someone this will make you money, that usually works pretty well, right? Like, it doesn't work as well with engineers, incidentally. But if you tell this to a business person, they will at least hear out what you're proposing, maybe not necessarily agree with you, maybe not necessarily, understand everything, but they'll usually hear you out on some aspect of it. So I think there's a genuine interest there, right? In that they want to know ways that they can have a competitive edge, where they can maybe, beat out the competition, where they can get more market share. But I think what that really says is knowing what their market is, knowing their product, knowing their business is really important. And this is across the board, not just in business, but, I think in any industry, where if you understand what it is they're doing, then it makes it a lot easier for me to then take data and give them back what it is that they're trying to do in a way that maybe they haven't seen it before. And I think making that connection for them, rather than, a lot of, I think, more novice data scientists or product people will often tell people what they think is the answer, but they're also, kind of being misled there, in that if you don't have experience in industry, it's not the same thing. And there is that balance that needs to be thought about. Maybe you don't have all that knowledge, but at least know where your gaps are. And so just offering what you think is better is not going to make someone feel confident about what you're saying to them, because non-technical people will not understand all the technical things the way a technical person will, and nor should I expect them to, because I went to school for many, many years and I did this work for so long. I think it would be foolish on my end to go expect someone without a math degree, without math background, to understand all the math so well. But I think being able to then take the math and show them the aspect of, the math that is of interest to them, that's something I can do, where I can make a connection with them, get them to see the value in it, rather than me just telling them, actually feeling that value. And then that will often generate more interest in actually funding a project, or finding out what else can you do with the data for me that, is super cool.
Brian, this is your everyday as well. Why don't you weigh in on your approaches and what you've viewed?
Oh, wait, am I being interviewed?
It's a conversation, right?
Yeah, I guess it is. What I like to do is I like to go through someone's like Twitter feed and their LinkedIn, all this stuff. And I'm just amazed by the diversity of interest that Jennifer has in this space. And I wanted to take the question the opposite way. Instead of work, and I brought up one that was from iCERN, and it was about the beauty of mathematics, and they actually were plotting out some algorithms on paper, it looked like, and they really were quite beautiful, and you seemed to be excited about it or something, and you retweeted something there. And it kind of got me because I see you as a businesswoman and a scientist, but I want to see also, what do you find beautiful? What do you appreciate about, even if it's mathematics, what do you appreciate about your practice?
Yeah, so I think having been gone to public school, I worked since I was 15, and I've always kind of like when I was not doing well in school academically, I did much better in practical sort of skills and doing like the job and being like paralegal or working as an intern at Morgan Stanley. And so initially, I think that helped me build confidence, and I like doing these more like direct, sort of like direct result, applied things, applied jobs, applied subjects. What was interesting, I think, for me in terms of going to undergrad and, having realized that I'm never going to get another chance, I really do need to take it seriously. I took it as an opportunity to do theoretical things because I'm never going to get another chance probably to go back and go to undergrad, and at least see, can I do it? Would I be good at it? I ended up in math partly because it was intellectually very challenging, and it allowed me to have questions answered that professors would never answer for me, teachers would never take seriously. But there's a course in mathematics called mathematical analysis, where you're basically building up all of the rules that we use in math classes throughout, all of our elementary school, junior high school years. And in mathematics, they actually go through and they prove it. They prove why it's true. And then they will also then say which rules are true. And if you go past that class, there's all these different subfields of math where it's, it is applied later on, but it starts out as a theory and theoretical. And yet every single one of those subfields have to have proofs. Like it isn't actually true unless you can prove it. I think math is one of the very, very few fields where that is something that is up to the person doing the work. It's not just about, did I collect data on, data from space? Did I collect data on this disease? It's something where you don't actually need the data points, and you can prove behaviors and numbers, prove, certain theories without actually collecting data. And yet it's the most useful, I think, when it comes to data. It can be applied the best in part because it's the most simple. It lets you have a way to think about very nitty-gritty, detailed data things in an abstract way where it's simpler, it's easier, and it's a little more holistic. And I always find that to be I think for me, I always say, like, I would never have gone into math if data didn't exist. My interest in math really was spurred on by the fact that I can make models and get data from computers that allowed me to then do math faster than I had before. I mean, it's taken a while, I think, for other mathematicians to maybe catch on to this idea of it, which is what was really cool about going to ISERM last month, because the research I presented was from about 8 years ago. At the time, NSF and NASA and all these other organizations didn't think it was anything. And that's the idea that you can merge these two things, this applied side, where I like to use data to show students why the math works. And on the flip side, I can use, the data to then prove things that show that mathematical theorems work. And it goes both ways. And then, of course, the other part of that is you can also visualize it. And that's I think the real beauty of math that I think gets lost, because a lot of people don't make it far enough in the field to see that sort of almost seamlessness in that you can have an equation that works out, and then the data that fits into the equation also works out. And then the visualization for that equation is also, it works out from a geometric standpoint. That makes it, so cool, because very few things in life will ever have that.
That is really cool, and I guess it's a bit of nature too, isn't it? And so I think we're coming pretty close to our 26.1 minutes, and I want to be respectful of people's commute time, and that's where that comes from, as I told you earlier. What's a couple closing things you'd like our 500,000 listeners to end with, and resonate with, what you're doing next, or where to find you, or whatever you like?
Yeah, so I mean, I guess a cool thing I'm working on next is working on some more space data. I was just a judge for this year's Space Apps Challenge at the Lower East Side Girls Club, and that was really, really fun. It was really cool. I think there's a lot of things happening with that data, and that's really cool. But I think people really need to understand that at the end of the day, every algorithm we use, there's math behind it, there's statistics behind it, there are these numbers behind it that you do need to understand to actually understand what's happening. And yes, all these services out there and this technology makes it easy and fast, but if you don't know how it works, then you don't know how it works. And there's a lot of money that you can lose that way. I mean, I know from experience, I've done that where I've used things like auto scaling, and it definitely did not go the way I thought. And it scales so fast that then you get charged a lot of money. There are all these sort of risks of what we take on that might be easy at the face of it. But then, of course, as you start using it, you learn the hard way that, in fact, it doesn't work out the way you think. And so there's this real value in being able to understand what it is you're buying, right? And understanding the math behind all these technologies and algorithms that we have. And I think the nice thing about doing that, although it is a lot of work, is that when you get it, when you have that moment where you're like, oh, I get it, it's an awesome feeling to finally understand that and understand like how the machinery actually works. And I think, I would always encourage people to think about trying to investigate the things that you're interested in and looking behind the curtain. And, if you're interested in it, just do it. You don't have to tell people, you can just do it for yourself if you want to, right? And there's a real loss in your own personal, I think, understanding and learning if you don't investigate that in this current day and age, because there's such an acceptance of us doing this type of investigation, this type of work, where that didn't exist when I was younger.
That's a wrap. Thank you for joining us on AI Podcast. You can reach us at ai-podcast.com or find us on Spotify or iTunes. Thank you again, and we'll see you soon.